been running dbt against Microsoft Fabric, you know the most frustrating part isn't dbt itself. It's the massive ecosystem you're forced to build around it. Up until recently, you needed dbt Cloud, or you had to spin up and self-host Airflow just to trigger a simple dbt run. Or maybe you were relying on some incredibly complex GitHub Actions. It was an entire separate system just awkwardly bolted onto your warehouse from the outside. Well, that awkward architecture fundamentally changed in December 2025. Microsoft actually shipped native dbt jobs directly inside Fabric Data Factory. We are finally moving away from those external systems to a fully native integration. You don't need a separate orchestrator anymore. You don't need a dbt Cloud account. And you don't need a dedicated CI runner just to invoke a command. It's now a native item type living directly in your workspace. So day to day, what does this actually mean? Your models, your tests, and your macros are now executing completely on Fabric-managed compute. The underlying environment uses a version 1.0 runtime, which is built directly on top of dbt Core 1.9. You're getting that core open-source engine running natively, without the sheer infrastructure headache of managing the compute instances yourself. But we really need to look at what that runtime actually connects to right now. Fabric Warehouse works natively, right alongside Azure SQL Database, Postgres, and Snowflake. But look over at the pending side. I'm going to be blunt about this. Native Fabric Lakehouse support is still missing. It's coming, but if your entire data architecture is built around the Lakehouse today, you're going to be waiting a bit longer to actually use this. There is also an important catch regarding community packages. If your project relies heavily on utilities like dbt utilities or dbt expectations, which, let's be real, almost all production projects do, that support only officially landed in March 2026. If you've been away from this native integration for a few months, you absolutely must double-check that your runtime version is active and updated. Otherwise, those package dependencies will immediately throw errors the second you hit execute. When you are ready to turn this on, setup is a very intentional two-step process. First up, the tenant admin has to go into the admin portal and physically enable the dbt jobs preview. You can toggle this for the whole organization, or you can scope it down to a specific security group if you want a more controlled rollout. Only after that's done can a workspace contributor actually create the dbt job item, assuming they have read-write access to the target warehouse and are operating on an active Fabric capacity. Once that job item actually exists in your workspace, hooking up your code is completely standard and honestly a huge relief compared to the old way. You just point the job at your dbt project using the exact same Fabric Git integration pattern you are already using for all your other items. You define your target connection, and your Git repository syncs right in without requiring any bespoke CI/CD runners. From there, you're just issuing standard terminal commands to run the project. You point to that target connection and type something as simple as dbt build directly into the interface. It feels incredibly familiar because it's just the core dbt command line experience mapped directly into the Fabric UI. However, you can also pass scoping flags like dbt run-select tag daily. And I want you to pay close attention to this, because using scoping commands with select flags matters significantly for native jobs right now. In fact, it is absolutely critical for avoiding a massive pitfall I'm going to warn you about in just a few minutes. Before we hit those limitations, let's look at how beautifully this handles scheduling natively inside a pipeline. You just add this dbt job as an activity inside a pipeline. Step 1, your ingestion step finishes. Step 2, only when that succeeds, the native dbt job fires. No more guessing with fixed clocks where dbt might accidentally run before your source data actually lands. And finally, step 3 shows every single run status, model timing, and test result flowing directly into the unified Fabric monitoring hub. It's one place to look, not a separate dashboard living somewhere else entirely. All right, now for the reality check. If you are actively deciding whether to move off dbt Cloud right now, you need to understand one massive limitation. There is zero build caching in this preview. None. Every single time you trigger a run, it compiles completely fresh from source. Absolutely nothing from a previous run gets reused. That naturally brings us to Slim CI, which relies on modifying state to avoid rebuilding your entire project from scratch on every single commit. Because there's no caching, that state-modified Slim CI pattern that a lot of teams heavily rely on simply isn't available here yet. If your team leans hard on Slim CI to keep your pull requests manageable and your build times down, that lack of caching is a real glaring gap today. It is not a minor inconvenience. And that leads directly to the most brutal hard limit for active practitioners. 1. Your run output logs cap at exactly 1 megabyte. The literal second you breach that 1 megabyte limit, your job instantly fails and throws error code 2001. Large projects with verbose test outputs or heavy debug logging hit this wall a lot more often than you'd expect. It catches people completely off guard because the pipeline didn't fail due to bad SQL, it failed just because dbt had too much to log. This strict log cap is the exact reason why that scoping command I mentioned earlier is absolutely mandatory. You have to use the -select flag to isolate your runs. You cannot just blindly build the entire project every time, or you're guaranteed to hit that 1 megabyte limit and crash. You have to be surgical with what you are running for anything beyond a very small project. Despite those limits, the environment management is actually quite elegant. CI/CD works right through Fabric's normal Git deployment pipelines, completely bypassing the need for a separate dbt-specific setup. You have your dev workspace pointing at a dev connection, a test workspace pointing at a test connection, and a prod workspace pointing at prod. The exact same dbt code moves through those deployment stages without a single change required. Fortunately, a fix for the caching and slim CI gaps is actively on the roadmap. Microsoft and dbt Labs confirmed in March 2026 that dbt Fusion, which is the brand new Rust-based engine, is coming to Fabric sometime this year. It directly targets these exact caching and state limitations, though it's important to remember it is not live just yet. So here is the pragmatic verdict on whether you should migrate right now. If your team is already fully committed to Fabric and you desperately want your dbt runs, your pipelines, and your lineage sitting in one governed place, you move now. But if you are managing a large project that fundamentally depends on slim CI just to keep your build times sane, wait for Fusion, or stay on dbt Cloud until that engine actually lands. What I didn't get into here, the exact admin portal click path, the full adapter compatibility table, the complete branching pattern for dev, test, and prod deployment pipelines, and the specific error code reference for every limit in this preview, all of that is written out in full in the guide. The link is in the description and the pinned comment. If you are actually enabling this in your tenant this week, read that first, not just this explainer.